Good morning, sir. Good morning, everyone. I am Jilly J. Salinas, and today I'm going to discuss about the particle interactions and conservation laws. So, what is particle interactions? Particle interactions follow strict conservation laws, ensuring total energy, momentum, charge, baryon number, and lepton number remain constant, acting as fundamental rules for what reactions are possible, with more specific rules like strangeness conserved in strong but not weak interactions, all visualized via Feynman diagram. This law dictates that if a process violates one of these rules, it is simply cannot occur even if it seems plausible classically. So, particle interactions obey strict conservation laws such as energy, momentum, charge, and quantum numbers that determine which reactions are allowed. Some quantities like strangeness are conserved only in certain forces. And if any of these are and if any conservation laws is violated, this process cannot occur. So, conservation laws. A conservation law is a principle stating that a specific measurable physical property within an isolated system remains constant over time. These laws predict a system microscopic behavior without needing to know the microscopic details of physical or chemical processes. So, a conservation law means that a certain physical quantity, such as energy or charge, does not change within an isolated system, even as the system evolves. This principle um, helps scientists predict how a system behaves overall without needing to know the exact microscopic processes um, involved. And then there are fundamental laws of conservation. So first we have the conservation of energy. So what is conservation of energy? Implies that energy can be neither created nor destroyed, although it can be changed from one form, example the mechanical, kinetic, and chemical, and to another. So this means that energy cannot be created or destroyed. It can only change form, such as from chemical energy um, to kinetic or mechanical energy, while the total amount of energy remains the same. And then conservation of mass implies that matter can be neither created nor destroyed. Processes that change the physical or chemical properties of substances with an isolated system, such as a conversion of a liquid to gas, leave the total mass or unchanged. So the third is conservation of linear momentum. It expresses the fact that a body or system of bodies in motion retains its of mass and vector velocity unless an external force is applied to it. So this means that the total momentum of a moving body or system stays constant as long as an external force acts on it, even though the individual motions within the system may change. And then the fourth one is the conservation of angular momentum. The angular momentum of each a bit of matter consists of the product of its mass, its distance from the axis of rotation, and the component of its velocity perpendicular to the line from the axis. So this means that angular momentum depends on how heavy an object is and how far it is from the axis of its rotation, and how fast it moves sideways around that axis, all of which um, together determine how strongly it resists changes in its rotation. So that is the angular momentum, that it depends now on how heavy an object is and how far it is from the axis of rotation. And then the fifth one is the conservation of charge. Um, this states that the total amount of electric charge in a system does not change within time at a subatomic level. Charge particles can be created but always in pairs with equal positive and negative charge, so that the total amount of charge always remains constant. So, ang conservation of charge daw is, it means that electric charge is conserved, so the total the total charge in a system stays the same over time. Even when new charge particles are created, they always um, appear in positive and negative pairs, so the overall charge remains unchanged. Dapat daw ang conservation of charge is ang ilahang charge daw is ang pair, which is the positive and negative, is always equal. And then the one is conservation, and next is the conservation of baryon number. So this process conserves charge, energy, and momentum. However, it does not occur because it violates the law of baryon number conservation. This law requires that the total baryon number of a reaction is the same before and after the reaction occurs. So, ang baryon number is, although this process satisfies the conservation of charge, energy, and momentum, it cannot happen because it violates baryon number conservation. This law states that the total number of baryons must remain the same before and after the reaction. And since this condition is not met, the process is forbidden. So, here's the baryon number. Di ka siya makita no kay something blurry siya. So, we have the electron, neutrino, sa manito kita. So, that is the baryon number. So, next is we have the lepton conservation of lepton number. Lepton number conservation states that the sum of lepton numbers before and after the interaction must be the same. So, ang conservation of lepton number states that conservation means that in any particle interactions, the total of leptons, like electrons and neutrinos, remains the same before and after the process, ensuring that the leptons are lost or created alone. And then next we have the conservation of strangeness. So in the late 1940s and early 1950s, cosmic ray experiments revealed the existence of particles that had never been observed on Earth. These particles were produced in collisions of pions with protons or neutrons in the atmosphere. Their production and decay were unusual. They were produced in the strong nuclear interactions of pions and nucleons and were therefore inferred to be hadrons. However, their decay was mediated by much more slowly acting weak nuclear interaction. So, ang conservation of strangeness in the late 1940s and early 1950s, experiments with cosmic rays discovered new particles not seen on Earth. These particles were created when pions collided with protons or neutrons in the atmosphere. So if ang pions is pag mag-collide na sila sa proton or ang neutrons in the atmosphere, they were unusual because they were produced quickly through the nuclear force like how hadrons, but decayed slowly via the weak nuclear force. So it depends on the impact of between the between the pions and the protons or neutrons collided. So um, for these reasons, these newly discovered particles were described as strange. So this is the diagram of a strangeness. And that would be all. Thank you.